name is Grace Mbwete, and in this lecture we're going to learn about integrity constraints and rules in databases. Why do we have integrity constraints? Integrity constraints are there to assist that the data in the database remain consistent throughout the update and the maintenance of the database. So what are the integrity constraints? Integrity constraints are the rules that force DBMS to check that data satisfies the semantics. Integrity constraints provide a way of ensuring that any changes made by authorized users to the database maintains data consistency. There are three types of integrity constraints. One is entity integrity, two is referential integrity, and three are domain constraints. So what is entity integrity? In order to ensure entity integrity in the database, it is required that every table or relation must have a primary key. Entity integrity defines a row as a unique entity for that particular table. Entity integrity ensures that a column which contains primary key value cannot have a null value. So what is a primary key? A primary key is a special column in a database table or relation designated to uniquely identify all table records. Entity integrity guarantees that every row of a table is accessible, whether you are retrieving data or modifying it. This means you can retrieve each row separately by specifying the value of a primary key. Let us look at entity integrity example number 1. Let's look at this table of employee, whereby you have 4 columns or 4 attributes. The first column is employee ID, the second column is employee first name, the third column is employee last name, and then you have a phone number. Out of these 4 columns or 4 attributes, the most attributes that satisfies condition of being a primary key is employee ID. This is because it's unique and it's available in every row in that particular table. We cannot choose a phone number as a primary key because someone might not be having a phone number. It's a choice, it's not a compulsory. But for employee ID, it's a compulsory value that every employee must have employee ID to identify him or her. Let us look at another example of a cause table, whereby you've got 3 columns or 3 attributes for cause. You've got cause code, you've got cause title, and cause description. For example, you cannot choose cause title or cause description to be a primary key because these are the things that can change at any time and can be similar. That someone might, if we look at cause code OIT 217's database and OIT 317, it's also a database. But when you look at cause description, you see the difference that 217 is for introduction to databases and 317 it's advanced databases. So cause code is the most appropriate column to be chosen as a primary key. Now let us look at a referential integrity. A referential integrity requires that a foreign key must have a matching primary key or it must be null. This constraint is specified between 2 tables, parent and child. It maintains the correspondence between rows in these tables. Referential integrity means that the reference from a row in one table to another table must be valid. Relational database systems provide enforcement of referential integrity constraints. Let us look at this example whereby you've got a table or a relation called customer, or you have customer ID, and then you have customer name. And then we have another table for order where you have order ID, you have customer ID, and you have order date. A referential integrity ensures that that every customer that is in the second table of order must be in the first table first. That means you cannot have a customer ID which is different or which is not available in the first table. At the end, you cannot assign an order to a customer who is not in the customer table. All those customers that in the customer table can have records or can have orders in the order table. And a foreign key is there to control the referential integrity between the two tables. Let us look at another example. We've got a course table and a lecturer table, whereby a course table has 3 columns: course code, course title, and number of units. And then we've got a lecture ID, a course code, and a lecture name. For referential integrity to hold, it is required that the course code that is in the course table, or in order to ensure that referential integrity holds, it means that all courses with course code that are in the lecturer table must be in the course table first. That there must be a primary key in the course table first for referential integrity to hold. When setting up referential integrity, it's important that the primary key and foreign key have the same data types and come from the same domain. Otherwise, the relational database management system will not allow the join. That means if the primary key from the original table is a number or integer, then the same data type must be the same in the referencing table. Well, that means the foreign key must be the same data type as the primary key. Now let us look at enterprise constraints. These are also known as semantic constraints. Enterprise constraints are additional rules that specified by users or database administrators and can be based on multiple tables. Now let us look at business rules. What are business rules? Business rules are very important in database design. These rules allow the creator of database design to develop relationship participation rules and constraints and to create a correct data model that is based on user requirements. How do we obtain business rules? Business rules are obtained from users when gathering user requirements for a particular database. Business rules allow the database designer to understand the business processes and the nature, role, and scope of data. Business rules give the proper classification of entities, attributes, relationships, and constraints. So what are the sources of business rules? Managers of organizations or the executives could be the good source of business rules when developing a database. Policymakers, written documentation for that particular organization, procedures, standards, and operation manuals. This gives the database designer ideas on how to develop constraints, relationships, attributes, and entities. Also, interview with end users, the users that will be using the database, whether the management or the normal employee of that particular organization. So, let us see at examples of business rules. This is for a scenario of an education institution. It could be college, university, or even a school. A lecturer or a teacher can teach many students. A class can have a maximum of 35 students. That means you create a condition or constraint in your database that a number of students does not exceed 35. When we say a lecturer can teach many students, that means the relationship is one to many. One lecturer can teach one or more students. A course can be taught many times, but only by one lecturer at any one time. That means it's a one-to-one relationship where we have a lecturer entity and a course entity. One lecturer can only teach one course. A course can be taught by one lecturer at any one time. And another business rule that can hold in education institution is not all lecturers teach classes. That is an example of business rules. This is the end of our lecture on integrity rules and constraint, where we've covered basic concepts of entity integrity, referential integrity, enterprise constraints, and business rules. Thank you for watching.